Hey everybody, welcome back to a new season of What's New in Data. Today we have a very special guest, Andy Pavlo. If you're in the world of databases, you probably already know his name. Andy is a professor of computer science and databaseology at Carnegie Mellon University. Andy has built a massive following with thousands of people looking to him for his insights and his flagship database course at Carnegie Mellon, which is fully open to the public online. What makes Andy's work so exciting is his ability to combine academia, industry, and a little bit of Wu-Tang Clan to make learning about databases gratifying, enjoyable, and practical. Let's get right into it. Andy, super excited to have you on the show today. How are you doing?
Hey, John, thanks for having me. We're talking about databases, so it's going to be a good time.
Always a good time talking about databases. Andy, I introduced you, but feel free to tell the listeners your story as well.
Yeah, so I am, as you said, an associate professor with indefinite tenure of databases in the computer science department at Carnegie Mellon. And it's my, I think, 11th year. I've been there since 2013. And prior to that, I did my PhD in databases at Brown University with Mike Stonebreaker and Stan Zadanek.
Excellent. Yeah. And like I said, many people follow you. One of the very interesting things you do is this very public course. It's officially a CMU database course, but you've opened it up to the public. Intro to Database Systems, CMU 15-445/645. It's generous how you made all the courseware, all the lectures, all the projects. You can submit projects. I went through some of them myself. Why did you decide to make it so, generously accessible?
Yes. How things started was when I started at CMU, I was pretty much the only database professor there. There was another professor, Christos Falutis, but he's in more data mining, graph mining world. And when you start off as a new professor, you're like, oh gosh, how am I to get tenure? Because I'm competing against the MIT, because there's Mike Stonebreaker and Sam Madden, competing against Stanford and the Berkeley people. So I'm like, all right, how do I get people to pay attention to what we're doing? And we decided just put everything on the internet. It's advertising for the Carnegie Mellon Database Group. And it's one thing to put the videos online, but also put all the course materials online. The thought process there was not everyone can get into CMU. And first of all, not everyone can pay for CMU. CMU is very expensive. It's not like they're paying me a lot of money, but it's a lot. And so not everyone can go to CMU. So why not just put everything on the internet for anybody who wants it? I don't know why more people don't do this. And the great thing about being a private school is I didn't ask permission. I just did it. And no one cares. Everyone's happy with it. So I'm glad to help as many people as I can. I will say the positive side of this has been, one is it forces me to be more professional. I say less crazy things because I know it's going to be on the video. But from a pedagogical standpoint, it's been helpful for me as a teaching and lecturing, because I'll watch the previous years, like from one year to the next, and I see where students ask questions. And I see, okay, they must be not understanding something that I'm explaining, or the demonstration or the diagrams aren't clear. So from year to year, I can look and see where students are confused and I make it better. So that's been wonderful. And the great thing also, I would say the personal satisfaction has been, people that aren't at CMU, like non-CMU students, send me emails and they say, hey, because of the course, I was able to get this job, right? And I got this internship. Like, it's helped their career. And then without paying CMU money, to me, that's fantastic. So I like those emails. I appreciate people sending them. So it's been nothing but positive.
Yeah, absolutely. And I want to say it's developed its own cult following. It has a Discord channel that's super active. Your videos are super engaging. They all start out like some sort of Tarantino movie. You're often in a beanie looking like you just ran away from a crime scene. And that really sets the tone going into the lecture. And then you'll go in and start talking about concurrency theory or log structured indexes and things like that.
I will say the phone call for this fall 2024, the phone call that I started that first lecture from the Carnegie Mellon police, that phone call is real. So people are like, oh, did I fake it? No, that is a real CMU phone call. And it's obviously not because I robbed a bank or something like that. Basically, I started getting these emails over the summer saying, hey, your CMU voicemail box is full. please go delete things. I'm like, okay, I didn't know I had a voicemail box because I've never hooked up my phone in my office. I can tell you about why in a second, and so I find where this website is. I realize I have 10 years of voicemails I've never even looked at, right? And so I'm going through, listening to them, see if anything I should keep. And sure enough, there's 2 phone calls from the CMU police. And the one that is on the YouTube video is because some woman not affiliated with the university, not a student, not a faculty, not staff, nothing, called the CMU police because they were saying that I had a photo on GitHub of me looking very threatening. And they were warning the police to have me take it down. It was something stupid like that. That phone call is because the CMU police is like, hey, this lady called and says you have a video or photo of you with a knife from undergrad, and we're asking you to take it down. Anyway, so like, yeah, there's been shenanigans, but not all of it is completely made up.
Absolutely. Someone really has to bring this mentality into the database world. And I think you've successfully done it. And I think that's why the community is so engaged. You have thousands of people following you for this course, and the Discord is super active. I went through the course myself. I couldn't get through. It's quite a bit of dense material. It's definitely reminded me of my college OS class. Shout out to the Pintos class taught by Greg Benson over at USFCS, but just nights and weekends in the lab. But the amazing thing is, even though it's very dense, very challenging, you have people in Discord who are chatting about going through the exercises. People are sharing hints, and also very generous in the community. For instance, I just shared the test output for the Hyperlog project, and someone said, "Oh, you just have like a little off by 1 error," and I said, "Okay, that's it. It was just my indexing was off." But it's very hard to get people to come around something that's so complex and work and collaborate and ultimately solve these problems. My personal recommendation is definitely try to go in with a group, but if you do, the community is awesome. Definitely shout out to you for cultivating that awesome
I would say also that Discord channel, that is not affiliated with me. That is some person in India is like, I'm going to make a Discord channel. He sent me an email. I'm like, okay, great, go for it. Like I don't monitor it. So that's all organic outside of CMU. So give credit to those guys for establishing that community. I had nothing to do with that, but I'm happy to see somebody did it.
Yeah, it's incredible. Definitely, if you feel like the material is really challenging, you just need some help. There's a lot of active communication there through every single project. But yeah, that's even cooler to hear that started on its own. Speaks to what's become a very viral course. The other thing I want to ask you is a strong background in Wu-Tang Clan an official prerequisite to the course or just recommended?
It's recommended. In previous years, not this past year because of other troubles, but in previous years, we've had a course DJ. We had someone, like if you watch the fall 2023 lectures, there's somebody sitting next to me, he's a full-time DJ, and he mixes and does beats before and after the lectures. And that's what basically we did that because there's a bit of a time setting up before the class starts and students are walking in. And it's always like this dead, awkward silence. So I'm like, all right, let's get somebody to play music during this time. So that's the Wu-Tang stuff came along because, one, I like the Wu-Tang Clan, but also we had a course DJ. So we plan on having one in 2025 in the fall. That's the number one complaint we got this semester is that we didn't have a course DJ. In previous semesters, I've done like Easter eggs or had for the final exam, for example, one year, if the student could list all the members of the Wu-Tang Clan that was what was on the original 36 Chambers album, including the one member who was actually in jail who couldn't be on the album, then I gave him 100% score on the final exam. So they had to list all the 9 members, but no one could do it. One guy got close, but he misspelled like Ghostface Killer and Master Killer. He missed the H on.
Automatic fail, right?
Yeah,
I didn't do it.
Had the exact names and everything. So yeah, we've done fun things like that before.
Yeah. It's really fun class. It's really engaging to go through. Sometimes the material can get dense once you're in the weeds of things, but it'll be funny to look up and see RZA and Jizza on the board and think, okay, is that some sort of acronym for an indexing scheme? Oh wait, no, that's from the Wu-Tang.
But let me comment on the density. The course I teach is like as you mentioned, the OS class. The OS classes at universities, those are expected to be very much dense and down in the weeds of like, here's what the kernel of the OS is actually doing. And no one really has done that for databases. It's always been the standard database course at most universities are like, here's what the relational model is, here's what the normal forms are. And then maybe that's the first half of the semester of like how to do database modeling. And the second half will be, here's what transactions are, here's what concurrency rule are. And when I first started at CMU, that's what the course I used to teach. It was a different number. And I used to co-teach it with the other professor I mentioned. And honestly, like I didn't like it because I just don't think it set up students for the things they actually really needed to know if they were actually going to go in industry and actually work on the internals of database systems. Nobody does normal forms. You don't need to know these things. Armstrong's axioms. So I threw all of that out. And that used to be for the time also when you used to search easy computer science courses at Carnegie Mellon, this old database course used to come up as number one. So I was like, I can't do, I got to get to that. So we threw it all away and I basically decided, like, here's the course that I would want to have taken if I was an undergrad of all the things I think are important. And that's how it evolved. And yes, I understand that like it can be a bit, you're down in the weeds. There's so much more material I could cover. There's not enough time in 14, 15 weeks. But I think that, and the expectation is not that everyone's going to retain everything that the course covers, but the idea is that when you go off in the real world, either if you're working on database systems or even just using a database system, which pretty much everybody has to these days in any application domain, that like you want to understand what the system is actually trying to do for you when you give it data or you want to run to understand what its behavior is. So that's, yes, it's dense, but it's not meant to be like, here's everything you need to like remember if you go out in the world, but it's enough to give you the background and say, okay, here's how things actually work.
Yeah, absolutely. It's an incredible class, and people who take courses like operating systems where you build the internal of a database or getting into computer architecture, people always say those are the most gratifying courses for computer science students in a lot of cases. So it's really cool to see the database lens of that, where, okay, the database is also this client to the OS and kind of restricted by the OS in a lot of senses. So we'll get into that as well. But a super fun course. I took my first stab at it, got through the first project and half the buffer project, and thought, okay, I need to block out more time for. I would probably have to take a sabbatical to really do the course justice. But I totally recommend it for a lot of folks, especially with the software engineering background who want to get more into database engineering. My brother's a CS student. I said, just go look at this class, just go snoop on this class since they don't offer the equivalent at your school. And he was very interested in it as well. So I do want to get into some of the materials in the lectures. Obviously, vector databases are heavily associated with AI in the industry. It's one of the use cases for taking LLMs and tying it to the database. In your course, you categorize vector database with other forms of indexing. So I want to hear your thought process behind that.
Yeah. So I guess we first explain what a vector database is. So a vector database, at least as it's been defined in the last couple of years, is a database system that supports taking vectors or embeddings. So think of a big array, a whole bunch of floating point numbers that are generated by a transformer. So you take your text document, you run it through this transformer, and then it converts it into this vector of floating point numbers or decimals. And then you build an index on that vector so that you can do quick approximate nearest neighbor searches. So the idea is that you take all your documents or all your data, you generate the vectors for them, you load it up into this index, and then now when a query comes along and says something to the effect, find me all the records that are similar to this other record. And that similarity can be based on the semantic meaning or a bunch of other factors that like your transformer could take into consideration. And then you do a nearest neighbor searches, and you find the vectors that are closest to the vector you're trying to search for. And so when you break it down to the components of what it takes to actually do that approximate nearest neighbor search, the first thing is that you store data that you're going to then build vectors on. And in all of the major vector databases, this is typically is JSON, right? You take your JSON, you identify which the fields you want to then turn into vectors, right? So that right there, that says, okay, well, you need something to store some kind of structured data, some as JSON, or it could be relational data, it doesn't matter. And then the proximate nearest neighbor search, that's occurring on this other data structure that it can do the nearest neighbor search. So again, if you just take out the AI, the veneer on top of all of this, so the undertone of it, say, okay, well, that's just a data store in an index, right? Could be a relational database plus a B plus tree index or a hash index, right? And so the proximate nearest neighbor search, that vector index, it's exactly as I'm saying, it is an index. So there's nothing radical or completely different about the idea that you want to do this nearest neighbor search on vector data that has to be a completely brand new like database system architecture. And when you go look at when vector databases became hot in like 2022, when ChatGPT became a sort of a household name, within 1 year, all the major relational database vendors had all added vector indexes, right? They didn't have to rewrite everything. They just added this new auxiliary index, just like if it was a new B plus tree or a hash table. So it is basically just that index. Now, there is some little changes you have to make in the query optimizer. Do you search the index first, or do you do it after when you want to do additional filtering? There's maybe you change the execution engine about how you actually invoke that index. So you're not getting exact results that may actually get filtered later on. But at a high level, the query processing approach on a vector index is about the same as it would be on a relational database or JSON database. So in my opinion, it is just an index.
Yeah, very cool to hear that perspective. And it definitely makes sense, especially if you look at all the parts that were adjacent to vector databases in your lecture. We talked about Lucene, for example. Lucene isn't necessarily new either, right? It's
Yes.
over a decade old. It's been around for a while, and you've seen approximate nearest neighbor search as a way to store and retrieve data for a while now. But yes, it seems like now it's viewed as one of the use cases for tying AI and databases together in the storage layer. We'll get more into that, especially when we get into your paper, what goes around comes around and around. But first, I just want to dive into the technical side of it. Another, yeah.
I would say one thing also, that the vector databases are going to do a better job at doing that approximate nearest neighbor than I think the relational database systems. Certainly one of the things they do better is integration with all the various AI tools or LLM tools, that sort of ecosystem, like LangChain and
Yeah.
those kind of things. Like they're going to do a better job of integrating those things. I know that Oracle has put out some stuff that can connect to OpenAI and other stuff more easily, but I think they'll do a better job at that. But again, the core architecture is essentially the same.
Yeah. It's always interesting to see the architectures that these companies have. There might not be anything groundbreaking or new in some of it, but the way they've built the database for the go-to-market around AI. Okay, how do we integrate it? How do we make it easy for developers to operate? What the people who are actually doing AI in a company, how do they work, and how do we make this really adoptable by them? I think those are the kind of ambiguous things that companies that are super focused on delivering something might prioritize over, let's say, an Oracle, but Oracle, I don't want to downplay them because, of course, there's a lot of impressive things they've done, and they're very focused on this area. But I would not say it's like a repeat of, let's say, NoSQL 10 years ago, where MongoDB was able to come into the market and Cassandra and others unopposed by the traditional vendors. So a lot of interesting things will happen there for sure.
I think the JSON story with Mongo is interesting because like Mongo became like a popular system 2009, 2010, and maybe even earlier, 2008. But it still took a few years before the relational incumbents added JSON support. I think Postgres added it in 2012. The SQL standard added it in 2016, at least the initial support for Oracle, maybe like 2013, 2014. So it took about 3-4 years before the relational data says, oh, this is a thing. Let's add it to SQL. Let's add it to our database system, which is funny because they already had support for XML, and going from JSON to XML it's not that radically different. So they could have repurposed some of that code to use it, but it took a while for it to happen. Whereas if you look at like the vector search stuff, and again, like I said, within a year of ChatGPT becoming like, this is a thing people want to do, and you want to do these RAGs or do these vector lookups and these specialized databases, it took a year for them to all to add that. And that either tells me that the effort it took to add a vector index and approximate nearest neighbor search to an existing system, like that was either easy to do because again, it's just another index you plug in, or, and it's probably a combination of the two of these, or people perceive as this is like a very important use case that everyone needs to have. It's the future. We don't want to be left behind. Let's go put all our resources at it right away. Within a year of ChatGPT blowing up, all the major databases had vector support. Whereas like with JSON, it took multiple years.
Yeah, absolutely. That's a great observation too. And just to see the signals going out there, Larry Ellison probably wasn't super excited about JSON, but he is going to dinner with Elon Musk and Jensen Huang and talking about AI and trying to build his own nuclear data center. So I don't think he's going to ignore this or let new vendors come into their territory here. It just has everyone's attention. And of course, the big hyperscalers too are also throwing a lot of IP at this. I could have seen why in, Mongo and some of the NoSQL databases and some of the more developer-oriented databases might have been able to take a lead in the early 2010s. Maybe the large established vendors said, that's just not our market. It's not super interesting to us. That doesn't seem like the case with AI. It seems like with AI, everyone's going full throttle into it. It'll be interesting to see what happens there. We don't even have an established, repeatable architecture yet for real-world AI deployments. There's some examples, but I think a lot of the work is still pending to see what becomes resilient. I also want to ask you about some of the other parts of your lectures. Without getting into too many specifics, I just want to high level compare columnar versus row based and some of the trade-offs there. Let's say, could you walk us through some of the deeper technical reasons why an OLAP system might prioritize columnar storage and compression, whereas an OLTP system, a transactional engine, might focus on row-oriented layouts?
Yeah, at this point, this is established conventional wisdom, so I don't think I'm breaking new ground here. But if you think of the original databases from the 1970s, 1980s, original relational databases, they would store everything in rows, meaning all the values or attributes for a single record or tuple would be adjacent to each other. For Andy's account information, you'd have my first name, last name, mailing address, like all that would be contiguously laid out one after another. And then the next record wouldn't start until the current record finished. We think the data to actually be organized in memory on disk. And for OLTP workloads or operational workloads, this makes sense because the queries are typically looking for single entities in the database. Go get Andy's record, go get John's record. And so when the query wants to go get that data, you want to land at some location and just read things contiguously and bring it back to the application. So that world that's storing things in the row store makes sense. For analytics, you're not looking at single records. You're looking at sort of the aggregation of all the data you collected, right? So you're extrapolating new knowledge from the collection of data you've accumulated. So in that world, you're looking across multiple records, and typically you're looking at a subset of the columns. Find me all the records within this zip code. So I don't care about your name, your last name, and so forth, right? I don't care about your birthday. Like those columns are all unnecessary for the query. I'm looking at just one single column. So people basically figured out in the 2000s, although the idea goes back to the 1970s, that if you actually store the data within a single column contiguously for every single tuple, break out all their composite attributes and store them just one after another, all the values within the column one after another, then that is better for these queries because now you can go jump to one location on disk or in memory and just read contiguous data just for that one column. And you're not polluting memory. You're not doing a bunch of IO to go fetch data that you don't actually need for the query. If I don't need the first name information about all your customers, why bring that into memory or why fetch that from S3 or from disk for the query? So that's the sort of the major distinction between the two. The workload sort of dictates how you actually want to store the data. But it turns out for the columnar organization, there's a bunch of other advantages you can exploit because now all the data within a single column are contiguous. You can actually start using compression and other encoding techniques to reduce the size of the data on disk. And then when you actually bring it in memory, other optimizations you can do to keep things in low-level CPU caches and allow you to rip through the data and process it more efficient. An obvious thing would be if I have a column with someone's sex, and keep it simple to say just it's male and female. I understand it's more complicated than that. Just say it's two values, male, female. So instead of just storing male, female over and over again, if I sort them based on the value, I can have all the males first, followed by all the females. And now I just need to record things like it's males, and I have 1 million males, and then followed by I have 1 million females. And now I'm taking what would have been 2 million records and starting down to just 2 records in cells to say, here's how many repeated values I have. So that's an example of run length encoding. There's other optimizations you can do, but if things are stored contiguously within the column, there's a whole bunch of other ways to make their data system run faster. And that's why so the modern columnar systems just crush anything that was built in the 1990s or earlier.
Yeah, and do you see this as do you see opportunities for convergence here? There's a lot written about kind of HTAP, hybrid transactional analytical workloads, or will Stonebreaker's quote, "One size does not fit all," still reign true for the foreseeable future?
Yeah, so I guess we first need to define what HTAP is. So hybrid transactional analytical processing. So it is a Gartner term. It's an amalgamation of OLTP or online transaction processing, which that I think dates to the 80s. And then OLAP, online analytical processing, that dates to the 90s. That was invented by Jim Gray, the Turing Award winner in databases. So HTAP is the idea that I can have a single system support both categories of workloads. On paper, this clearly makes sense, right? Like, why provision one database for your transactional workloads and then another database for your data warehouse or your analytics? It'd be great if I could have a single system just do everything. In practice, though, the challenge is that oftentimes there's the stakeholders at an organization are typically separate, meaning the people that want to run the transactional system are not the same people that want to run analytics. And if you come along now with a system that kind of does a half-ass job on both of them, the stakeholders for transactional stuff is, why would I want this sort of handicap system that can do both? I only care about transactions. Give me the best transactional database you have. And likewise, the data warehouse people are like, I don't care about transactions. Give me the best OLAP system that you have. And so oftentimes selling an HTAP system can be challenging because the people that are writing checks for the software often have different needs or different desires. I will say, though, what makes sense is that if you can have some minor support for, I think, analytics on the transactional side of the things. So I don't think it makes sense to have, or it'd be very difficult to sell a full-fledged transactional database system bolted on top of your data warehouse. Like Snowflake has their hybrid tables, but that's certainly not meant to replace a full-fledged system like an Oracle RAC or say like an Aurora. But it can do some transactional stuff, which makes sense for certain workloads. But you wouldn't want to run your like full-fledged like front-end application on top of that. And so on the flip side, if you add some support for analytics on the operational database system, I think that makes sense because now you can do some minor analysis on the data as it comes in, rather than having to wait for it to stream out to your data warehouse, get processed, and then do analytics, and then send the results back. But certainly we wouldn't want to run like heavyweight analytical jobs on the transaction system all the time because that's going to slow things down. Now, there are systems that do the hybrid approach, which I think is the right way to do, is what Oracle does is called fractured mirrors, where you basically have the row store, all new data comes in, gets stored in the row store side of things, and then they make a copy of the data in like a column store format. And so now when a query shows up, you can figure out, okay, is the data I need, does that need to touch the analytical side? Therefore, I run on the column store, or do I need to run on the row store side? I think that's probably the right way to go, but trying to build a full-fledged column store that can do transactions at the same speed that a row store can, I think that's challenging.
And that's one of the interesting things you're bringing up, is that they're both better at different things, right? The columnar engine is generally better for these large scale analytics workloads. People are trying to get a approximate sense of some metrics in their business, whereas these transactional workloads, you're thinking, okay, this is your ATM system, your travel reservation system, your health records. All these things are very operational. What's an example of some of the actual technical trade-offs going on there?
Of like why you don't want to run analytics on top of the row store, or
Just in terms of, how, a transactional system, like what is a transactional system prioritizing that an analytical system can't do, for instance, very well?
so a transactional system is it wants to run transactions. And so in that world, it's all about minimizing latency, usually the P99. So trying to be able to execute queries and return responses to the application as quickly as possible. And if you start running with transactions, either through the concurrency protocol, whereas the database system is trying to make it look like you're running by yourself when you're actually trying to interleave multiple queries and transactions at the same time. In that world, you want things to be done as quickly as possible because they're holding locks, or they are doing much other bookkeeping on the inside that could slow down other transactions. So if your transaction runs slower, there's this butterfly effect where that's going to cause other transactions behind you to get slow. And so I mentioned the fractured mirrors, or the split row store column store approach. Is like you could run sort of way to do isolation to say, for all my data, for all my transactions that touch row data, I can run those as fast as possible. And maybe the slower analytics, they'll run on the side here on the column store data. And if I build my system a certain way, like they don't have to communicate about like who's reading what data, what time. I can just let the row store run as fast as possible. So the priorities for what you would care about from the application perspective in the transactional system are just different than the column store system. And that causes you to make different system design choices.
Yeah, absolutely. And I think there's always, in the markets, you always see this attempt to unify everything. Okay, we're going to unify transactions and analytics. We're going to unify batch and streaming. But I always get the consensus that people who've done this for a long time will always say that there's a lot of trade-offs going on there. It's hard to actually do both of those things well. This again comes back to that quote from Michael Stonebreaker, which is one size does not fit all. And yeah, it's one of those interesting things that like you always want to see. It sounds, when you look at it just at a high level, intuitive level, yeah, why wouldn't someone want to just have one storage engine that does everything for me? I think like from a layman's perspective, you think that would just be like a killer product for the market. But when you work on this stuff, that there's a lot of technical trade-offs going on, which you can explain here as well.
But the reason why I don't think the HTAP stuff has really taken off is, again, it's what I was saying in the beginning. It's not oftentimes technical, right? So if you think about how, say you're building a new application from the very beginning, whether you're a startup or inside of a company, what happens? Well, in the very beginning, you don't have any data, right? And so you're building an application to then interact with the outside world or some other outside thing and to collect new data. You'll make a web app, you'll make a new application that can ingest data from the outside world. At the very beginning, you don't have any data. You need to get data. And so you're building essentially a transactional database application because you're ingesting things from the outside world. You're updating things, updating state. At the very beginning, you have nothing. So you start with a transactional database system like a Postgres or whatever. And so now you start ingesting data. Then typically the path for growth for these applications is not the next day you had one day you have one user, the next day you have 1 billion users. That is rare. It happens, but that's usually not the case. So it's a gradual increase of usage and new features get added and new data comes in. So the database is gradually growing over time. And then at some point, you say, okay, now we do have data. Let's run analytics on this. And so at that point, you either try to run analytics on the data you have, and maybe it does okay, but not great. But then you say, okay, I don't want to touch this operational database, this transactional database right now. Let me start offloading the data to a data warehouse, a Snowflake, or whatever, to start running analytics on that. So then over time now, these two things are growing up separately. And then the HTAP market is basically trying to say, okay, these things grew up together, but separate as the siblings. Let's now go sell you something that's going to go sit in the middle and can do both. And it's very hard to sell a database system to replace a working and functional transactional database system because the risk is so high. So you're saying you're running Postgres, you're running Oracle RAC or whatever on the transactional database. Go get rid of that and replace it with my new database. But if that new database fails, then you're screwed because now you can't take in new data. You can't run orders. You can't take payments. You can't get new data. Whereas if on the data warehouse side, you can still keep up the old data warehouse. You just make copies of the data into the whatever the new product you have. And if it fails, no big deal because you're still ingesting data in your transaction database, and you can always roll back to the other data warehouse. So the barrier of entry to replace a data warehouse is much lower than it is to replace a transactional database. And so now if you're trying to say, I have an HTAP database, you're still going to face that same barrier where people don't want to fix what's not broken. So it's very hard to get people to replace a transactional database once it's grown up and been around for years. There's a reason why IBM still makes a ton of money on IMS. That they built that database for the moon mission in the 1960s because people don't want to break stuff that if it's running just fine, or don't want to change it for the sake of changing it.
Yeah. And that's such a great point. Like practically it'd be very hard to take that to market because, okay, you have your CTOs and teams who've already built the applications running on top of the transactional database. That could be in place for, let's say, a year, it could be 40 or 50 years. And then you have this new CIO, this chief data analytics officer, whatever you want to call it, who wants to come in and say, hey, I want to unify analytics across all my systems. The transactional system is just one of my sources. And then I also have my marketing data. I have my third-party data, just get that all into the analytics warehouse. And then I'm going to have, who knows, hundreds to thousands of data scientists and analysts running queries on that thing, right? And then from that perspective, you can see why it would be hard to say, okay, hey, transactional database owner, let's onboard all these analytical users for you. And then that would be its own kind of logistical nightmare and technical nightmare. Like how would you do that without impacting the production operational applications? It's definitely very cool when you see some of the new technology coming in. Let's say, for instance, DuckDB. I know that's in some of the exercises in your course as well. I did like that part of the SQL exercise where you run some queries in SQLite and then put a timer and run the same queries in DuckDB, and it's just automatically faster. And for me personally, I use both DuckDB and a data warehouse, and the product I work on does change data capture and data streaming. We'll always stream data out from our transactional database into our warehouse with Striim. But there are some kind of in-situ and analytical workloads that we want to put on top of the operational database. DuckDB's been awesome for that because you can just, in that same application that's managing the database, I can just instantiate DuckDB and it'll do these super fast analytical queries. And that just solves our problem. It's not super scalable, but it's fast and it works.
Yes. DuckDB is fantastic. I think what Mark and Hannes have built is phenomenal. I'm jealous. Not in I hate them way, but they built a database system. I like building systems, and then they got people to actually start using it. And I think they had the idea this thing needs to be super portable and have a low barrier entry from the very beginning. And I think they crushed it.
Yeah, and the out of the box performance is always awesome. Engineers love publishing mini benchmarks of their internal workloads, and it's always a big win where I can go show my manager, hey, look, we sped things up by 5-10x by throwing this technology in there. Of course, my management are all very incredibly smart people, had a ton of questions. And I said, oh, okay, well, we're not solving that problem. So we just solved this problem and increased the performance there. But there's always some excitement around performance gains. So we talked a bit, I mentioned Michael Stonebreaker's name. you did as well. I said it in the context of one size does not fit all, but you recently co-published a paper with them called "What Goes Around Comes Around."
And around, yes.
I want to hear the story behind that paper.
Yeah, we should preface by saying Mike wrote another paper with Joe Hellerstein at Berkeley in 2006 called "What Goes Around Comes Around," and so our paper in 2024 is the 20-year follow-up to this. So I guess for the background people don't know. So Mike Stonebreaker won the Turing 1 databases in 2014. He's the inventor of Postgres. Prior to that, it was Ingress, but he's been involved in the database game for a long time. He's brilliant. So he wrote a paper in 2006, and basically it was a historical summary of all the data models going back to the hierarchical and network data model, which predates the relational data model in the 1960s. And basically shows that like there's all the attempts to try to build something better than the relational database, a relational model. And here's why they're not as good. Here's what doesn't pan out. And here's why the relational model, or as he puts it, the object relational model, which is what technically Postgres' data model is. It just means it's a relational data model that's extensible. Why this one is superior. And so I think it was during the pandemic, it was like 2020, I saw a Hacker News post where someone was like, hey, I don't know why people are using relational databases. We should just use graph databases for everything. And I was like, oh man. For my proselytization of the relational data model, I feel like it's basically Mike's thesis of what goes around comes around, where people are just like reinventing the wheel over and over again. So this person saying, why are we using relational databases? Why aren't we using the graph databases? They're just unaware of, oh, people tried that with this thing called Codicil, the network data model in the 1970s, and it didn't work for reasons X, Y, Z. So I just felt we wanted to put out another paper as a follow-up and say, here's what all the things people tried in the past, if you don't know your history, and here's why the relational data model is going to be the best or the better. And so we wrote the follow-up paper that came out this year, and it's basically a updated analysis of data models that have come out since the original 2006 paper. We do discuss key value stores, which predates that. Like key value stores probably late 80s, early 90s. But we cover array data models, metrics data model, vector data model, the document data model, graph data model, and then sort of MapReduce really doesn't have a data model, or text search doesn't really have a data model, but we discussed those as well. So that's the first half of the paper. And the second half of the paper, which we haven't talked about too much, is the developments or advancements in database systems since the early 2000s. And the main takeaway from that part of our analysis is that most of the improvements and advancements have been in the context of relational database systems, like cloud architectures, hardware acceleration, column storage we've talked about before. There was this sort of group of systems called NewSQL, where they kind of do high performance distributed transactions. So we basically talk about, here's all the things we all tried, here's what worked, here's what didn't work.
Yeah. And it's really important that you put out papers like this, because I don't want to get too much into this. New database companies are really good at marketing. In a lot of cases, they do have a lot of value, but sometimes they'll make claims that are a little hard to defend when you look at it objectively. So
Self-defense. It's quite often, right? I forgot to take shit on blockchain databases. Like blockchain, that's another one. They're like, why would you ever want to store things in a relational database? You just use a blockchain. No, it's stupid, it's slow, it's wrong. Here's why. So yeah, it's basically, how to say this, instead of me having to do like a Google News alert or something to find out every time people are saying like, hey, relational databases are stupid, SQL is stupid, here's a better one. Instead of having to have me go reply to them automatically, just write this paper and people can point at it. And then 20 years, people forget we wrote it and we have to write the next one.
Yeah, amazing. And I'm sure it won't be hard, because I think 98% of what you wrote in this series paper will probably be relevant in 10, 15 years as well, and probably just need to be restated and republished. I did want to get some of your perspectives there on data lakes and data lake houses. You did mention that they've emerged to challenge the monolithic data warehouse. There's, of course, all these conversations going around Iceberg and Delta, and course, Databricks bought Tabular, which is the
For a lot of money.
for a lot of money. And now AWS created S3 tables, which will manage Iceberg tables from their perspective. AWS is probably seeing all these people managing tables on top of their object layer on S3. They're probably saying, hey, why don't we just do that? I want to get your perspectives there. Do you think it's a resilient technology that a lot of companies can go ahead and adopt, or do you think that there's some challenges ahead there?
Yeah, I guess we first want to define what a lakehouse is, or a data lake. So the way people ran data warehouses before the data lakes was that you would provision a very expensive machine or a large number of machines, and that would be this monolithic architecture where you would put all your data in for the organization. And so it was, the data system was basically the gatekeeper. So if you want to store data in your data warehouse, they do analytics on, you had to define the schema, you had to provision the hardware, or you get permissions to put it in, and then you would then insert it into the database. And the database system would do what we'll call managed storage, where they were responsible for ingesting the data, organizing the actual physical bits you would then store on the disk, right, and maintaining that information. So with the data lake architecture, the idea is that instead of having everyone to go through a central control of putting data into this data warehouse, you could allow anybody just to write a bunch of files to S3 or whatever your object store that is. And then the idea would then be, if someone wants to then do analytics on this data, they wouldn't have to go through, again, to the data warehouse. They could just grab the data off of S3 or whatever your object store is and process it there. So these files, worst case scenario, it's just a bunch of JSON or CSV, like text formatted data. But things like Parquet and Orc, these are now binary encoded columnar formats that be as if it was being organized by the data system, but there's libraries that generate these files yourselves and just write those things out. So that's the idea of a data lake, is instead of having everyone go through a monolithic data store, you can just put things out in S3, and then you would use a catalog service like Databricks has Unity, there's HCatalog, there's now Snowflake Polaris. It'd be a way to go find the data that you want in these files. So the lakehouse architecture is basically a middleware or a query engine on top of the data lake that provides a SQL interface to go run queries as if it was in managed storage from a data warehouse, but actually it's just on S3. Dremio, Databricks are examples of this. So that's the background there. Where Iceberg comes in, there's also Hootie. I think there's another one I'm forgetting as well. Delta Lake from Databricks. What those are, instead of having people just in their application code generate the Parquet file and then shove it into S3, now you have a sort of interface where you can do insert, update, deletes on essentially looks like relational tables on files as if they look like tables to you, but underneath the covers it's just JSON and Parquet. And then Iceberg, or these different middleware, they're responsible for collecting the information, running transactions for you if you want to update things, and then compacting, coalescing them into Parquet files that you then write out to S3. And then again, they would also provide the sort of catalog service, so you know what files correspond to what tables and so forth. As you mentioned, Iceberg is considered the standard out. Iceberg came out of Netflix. Hootie came out of, I think, Uber. HCatalog came out of the Hive project, which came out of Facebook. So there's Iceberg, people have coalesced on that as being what the standard is. And as you mentioned, Amazon now supports it natively, although they had support for native Parquet Select as well. But although they haven't deprecated it, but you can't get it now if you're a new customer. But like existing customers can still do basically predicate push down or filtering on Parquet files directly inside of S3. So Iceberg looks like it's going to become the standard. The backstory is that Snowflake has slowly been, or has incrementally added support for Iceberg, I think since 2002 or 2021. And then they were in talks of buying Tabular, I think for $600 million, either early this year or late last year. And then Databricks came in and just threw $2 billion at them in their face and stole them.
On the day of the the Snowflake Summit's CEO's keynote session where he was announcing their Iceberg support. So
Hilarious. Yeah.
nice catalog.
And then the next week at the Databricks, I guess, summit, they announced that they were open sourcing the Unity catalog. Yeah, but I say Polaris, I think it's rewritten in, I think it's in Rust or C++. It's not written in Go or Java. And it has become an Apache project, so it's not just Snowflake building it now. Dremio is involved, a bunch of other companies are involved. So yeah, basically Iceberg is now the standard. Underneath the covers, it's basically, again, as I said, JSON files and Parquet. So but I think the interface to the catalog and the transactional updates, that's, people have sort of coalesced around that. Do I think this is like long-term how people are going to build things? Absolutely, yes. I think the idea that you're going to have a monolithic data warehouse where some administrator is going to have complete control over who could put things in and out, you're still going to always have that kind of governance. But I think the disaggregated architecture of something like Iceberg is the way to go. It just makes sense, because why spend a bunch of engineering resources to make a storage layer if you're trying to build a system? Just rely on S3. It's infinite storage, infinite in quotes. Obviously, Amazon, there's a finite limit, but you'll run out of money before you can fill up S3 on Amazon, whatever, or GCS, whatever it is. So I think this is the right way to go. This is basically how you want to build a modern OLAP system. So I think it's sustaining. I don't see it changing anytime soon.
And do you trust that Iceberg is the best table format this time?
When you say Iceberg best table format, it's Parquet underneath the covers.
Mm.
Do I think Parquet is the best format? No. Parquet was designed in 2013, 2012, and in a totally different world, where disk was always considered the slowest thing, and therefore they had heavyweight compression to minimize the amount of disk I would have to do. The hardware has changed enough that like network and disk are actually pretty fast, and the CPU is actually becoming the bottleneck. And so we have a paper that came out in DuckDB last year that did analysis on Parquet and Orc and basically showed, here's a bunch of assumptions that they made back in the day that don't make sense now. And we've been pushing for a sort of a new format based on this, which I can talk about. Microsoft put out a paper around the same time as ours, basically found corroborated results, found the same thing. Parquet and Orc are old. So we have a line of research that is trying to build a new file format to replace Parquet and Orc. And we're not so much interested in, here's the encoding for the different columns. And like I mentioned before, doing this run like encoding for column store data, like there's implementations of that. I don't like, that's going to evolve over time. I'm more interested in like the scaffolding around a file. So how you could define what the file should look like and how you store the metadata to say, here's how the data is actually being encoded. So the reason why this matters is if you want to add a new encoding scheme to Parquet right now, you can't do it. You'd have to go modify the original Parquet code. Then also this makes your data not portable, because if my application is not using my modified version of the Parquet reader, which there's a bunch of different implementations, different languages, then I can't read this new encoded data that I have. And so we're interested in building a new file spec that allows for the portability and extensibility, so that we don't have to reinvent the wheel every 10 years with a better version of Parquet. We can just build one file spec similar to as POSIX, one spec that has evolved over years, but like it's standardized. That's what I'm interested in doing, is building that specification, not like, here's whatever we want for this exact hardware that we have right now.
Yeah, that's exciting for sure. And it will become I think every 4 or 5 years, the architectures shift a little bit. People standardize on one approach. I think the vendors hyper optimize selling around that approach, and then things magically become too expensive again. And then people find a way to make architectures cheaper and more distributed and get more components into place that you compose. So I think, yes, coming up with a file format that's more efficient and extensible, I think that's also a very exciting area, and will be cool to see how that gets plugged into some of these. Yeah.
Can I give you a preview of what makes this, how we're going to handle it, sort of future-proofing this thing?
Please do.
I would say also too, like we have our format. We were actually in discussions with the Velox guys, they put out a file format called Nimble. We were discussions with NVIDIA about some stuff. Like, we had a larger collaboration in the works, but for lawyer reasons, it all fell apart. But Facebook has, or Meta has, their Nimble file format. There's LanceDB has their format. There's another system out of New York City called SpiralDB. They have Vortex. The DuckDB, the CWI team has their own file format. So there's a bunch of sort of formats going around. As I'm saying, I don't want to build, I don't want to have a competing format. It's more about the scaffolding. And so the way we can handle extensibility and portability is that you actually embed a WASM binary to decode the data in the file inside the file itself. So now, 10 years later, if I have some file that was created 10 years ago that I don't have the code to actually go process it in natively, I can process it using the WASM that's embedded inside of it. And so this, again, this allows you to future-proof the architecture. I fully admit, we didn't invent this idea. This actually came, the change came from Wes McKinney, who's been working with us, the inventor of Pandas and Apache Arrow, but he actually got the idea from Mark and Hannes at DuckDB. So this is our new file spec we hope to put out this year will be incorporate this WASM piece.
Okay, excellent. Definitely looking forward to that. Again, a lot of excellent ideas floating around right now in the data industry. It's really fun to follow along with. How does, let's say you are a software engineer working in data, or even all the way up to a CIO level, how do you, what's your advice to stay educated and make people's technical skills resilient in this industry? And emphasis on resilient, meaning, yeah, you could learn one technology, but that technology could, become out of date in 10 years. And at this rate, everything's gonna be out of date in 6 months. But I'd love to hear your advice on staying resilient in this market.
So this gets into, what does it mean in the modern era to have let's say a degree in computer science, right? 'Cause I'm in that business of selling education. And without touting too much about Carnegie Mellon, the other top schools, I think, make a similar attempt at this, right? It isn't about learning, here's what the hot thing on Hacker News is, learn how to use it, and so forth, right? It's about first principles and the fundamentals of the concepts needed in data processing, data analytics, databases in general. And so as long as you understand the fundamentals of what does it mean what is a transaction actually trying to do? What does it mean to have protection, or the isolation and concurrent control and durability? If you understand those fundamentals, then no matter how the hardware evolves or the workload evolves or the use cases evolve, that you can always map whatever those new things are to to your background, to the fundamentals. So I would say for developers, I think understanding the fundamentals is key. For the higher level, like for a CIO, how do you make sense of whatever the buzzwords are? The challenge there, again, it isn't always for technical reasons why you make a choice to go with one vendor versus another. Oftentimes it has to be, do I already have my credit card with this company, and therefore they can sell me another product, and it's just easier not have to go through procurement to be able to get access to it. I would say that at the manager level, I think being skeptical about claims that people make about their products it's always better to be more skeptical than less skeptical, right? As you said, when people come along and say, hey, here's my brand new database system or technology that can change the world and give you everything you need, you really understand what your use case is and understand what this company is bringing to the table, and then understand, okay, here's what the actual architecture, what they're actually doing, how it's actually implemented, to understand, is my use case even going to make sense or not? The example I always like to use was in my classes is this episode at Uber, I think in 2016, where they were running on Postgres. They're running on MySQL. Someone said, hey, let's switch to Postgres. So they switched to Postgres. And because of their application's workload patterns, that was actually a terrible choice. Like Postgres, the way they do multi-versioning and so forth, that was absolutely the worst thing you could do for Uber. So then they had to go switch back from Postgres to MySQL. So it had someone understood, like what is our application actually trying to do? What do the queries want to do? What does the data actually look like? What is the access pattern? And then understanding, again, the fundamentals of like how Postgres does multi-versioning versus MySQL does multi-versioning. Like you could then map and say, does this make sense or not? So I think it makes sense to understand what the internals are for certain things. And then as new things come along, it's very unlikely that someone's going to invent something crazy brand new that no one's ever thought about before. And so it's getting past all the marketing BS to figure out, okay, what are they actually doing? And then understanding how that maps to your needs.
Absolutely. And I think that's great advice, both for the data engineer, the software engineer, and the CIO, is ultimately understand the first principles and then be a little skeptical of vendor claims, because there's really, even when things seem very new or companies raise a ton of money or something like that, it's rarely completely novel, something that no one's thought of before. Maybe they found a better way to commercialize it than others, but yeah, there's always a bit of work to do to actually test this stuff. So the other thing I did,
Can I give one example without naming
Yeah.
names?
yeah, sure.
So
Go ahead.
I got an email from a CEO at a database company that you've heard of, but I guess who they are. They sent me an email and said, hey, look, I watched your lectures on distributed architectures. There's like shared disk, shared nothing. We think we have a new architecture that doesn't fit in any of these. We think it's brand new. We want to tell you all about it. So I got on the call, talked to him, and sure enough, like it was just shared disk, separating compute versus storage. And so again, without understanding the history and the background and the fundamentals of these things, people would make claims that like again, that wouldn't pass the sniff test for anybody again who does know these things.
Yeah, absolutely. And my job, especially as a building change data capture and data integration, is constantly straddling all these different new age technologies and replicating the established vendor storage engines to them through change data capture and mining the logs and things like that. You really do see a lot of these decisions are mainly, I think the hyperscalers have solved the scale issue for sure for companies that actually need scale. And I think that there's a lot of great technology coming in to make this stuff more practical for enterprises to implement. Now, the other side of this is, of course, there's all this innovation happening in AI and machine learning, and you spoke on this in your paper as well. Which architectures and capabilities would you say are absolutely critical to adopt for a CIO or a CTO to build into their strategy over the next 3 to 5 years to actually realize the potential of AI?
In terms of like database type architectures or machine learning architectures or both?
Yeah, and that's a good question too. So,
Actually, the answer it doesn't matter, right? Because here's what matters. If your data is dirty and it's total crap, then who cares if you're running on whatever NVIDIA's latest GPU or whatever. If your data is super dirty and messy, garbage in, garbage out. So I would say putting up regardless, actually, if you're going to do AI stuff anyway, putting up the right controls and the mechanisms in place to make sure that people can't give you crap data is super important. And it's hard to justify because it's like, hey, we think we might need this in 3 years. So let's do a bunch of stuff to make sure like our data is clean now. Yeah, like that sucks. But I would say that's the most important thing. If your data is completely useless and garbage, no AI magic is going to make this better for you.
and when you say useless and garbage, let's say big enterprise database, you have hundreds, maybe even thousands of these kind of normalized tables with column names that no one can really make sense of, tons of foreign keys to actually get any data. And people are saying, okay, we're going to throw vector databases at this problem. And the first thing I think is, okay, try getting like a human analyst to go through all these tables and make sense of them without reading a lot of like internal documentation. Do you actually see like AI solving that problem?
It will help. So certainly like entity resolution, like the idea that like John Kutay versus Jay Kutay, like realizing that they're the same people, that's an old problem. And absolutely, I think LLMs or AI tools can help with this. But like I'm saying, if it's W Kutay versus J Kutay and it's someone did a typo, then you're screwed. It doesn't matter.
Yeah, I see.
So I think that's a contrived example, but there's other. Another example we can always give is like, oh, someone put an email address instead of a phone number. Sure, like that one you can check for as well. But it's the nuances of like really large databases and what the semantic meaning is, the latent or implicit meaning of like, what does it mean to have this column empty versus null? like all of that is usually in the application domain and oftentimes isn't documented. And so if you can prevent that from happening, easier said than done if your data is running for 20 years. But I think that would set people up to better leverage whatever the new AI stuff that comes along in the future.
Yeah, that's a great point. And I think cleaning up messy data, there's all these kind of master data management tools out there, and there's a lot of people who claim to have great solutions of that. Ultimately, when you see it happen in large companies, it's just someone's just got to grind and go through that work. And I think, yeah, there are some opportunities for LLMs to go solve those problems. And the one of the other approaches to this, aside from vector databases, is Texas SQL. They're not totally mutually exclusive, but Texas SQL, this is idea that you have this natural language query and then know how to convert that into this deterministic SQL query that'll go in and retrieve the exact data that you're looking for. Do you see that as being a strong alternative to vector databases, or just a different approach that could work well with it?
I think it's independent of whether the underlying database is relational versus vector versus JSON. But as you said, the idea of going from natural language to a structured query language, typically SQL. First of all, it's as oftentimes in databases, it's not a new idea. People have been trying this since the 1970s. LLMs are just the modern incarnation of it. I think it's a good idea. It doesn't replace SQL entirely. It's good for quick one-off things. The problem with the challenge course is if I don't know SQL or if I don't know what the answer is. If I knew the answer, I wouldn't run the query. But then be able to take my natural language, generate a SQL query, and then get back a result from that and to know whether it's actually correct or not, that's a challenge right there. And there's some benchmarks that can on existing data sets to try to figure out how good you are. I think that the challenge is going to be that the English language or whatever natural language you're using is imprecise, whereas something like ideally SQL would be precise, but it isn't always. But like the idea that you're going from an imprecise language to a precise language and then try to tweak the natural language to make it then contort if it's not exactly what you want, that's a big challenge. Where I see the natural language tools or these converters being useful for is as the first attempt, give me a SQL query, but then I can then somehow show a more structured form or interface that I can then tweak it by clicking buttons in like a dashboard or something like that. So as a first pass, but then put that into a form that makes it easier to edit. That's where I see the future of this being. But like for one-off things, the results are pretty stunning. But you wouldn't write your application doing this. So you wouldn't like build a web interface or a website where you have like natural language in the queries, because if the LLM model changes, then the query changes, and then everything breaks. What do you do? But for one-off analytics, I think this makes sense.
Yeah, absolutely. And I think this also comes back to the differences between the operational transactional workloads and the analytical workloads and the search workloads. And ultimately it comes down to smart people designing their applications the right way, rather than assuming that AI is going to sort of, I don't want to say idiot proof, but make everything really accessible to, let's say, just natural language business users who don't know how to write SQL. I think that's, like you said, that's been a challenge for a long time.
But go beyond natural language, though. If you're taking English or whatever natural language you want and going to SQL, why not go from whatever query language you have now to SQL, or whatever SQL to whatever query language you want? So you can think of these things as actually being this intermediate bridge that allows for portability in a way that we didn't have before. Now, the challenge, of course, is going to be there's nuances and the semantics of certain operations that make sense in one data system versus another. But it's very hard to get off Oracle because the syntax is slightly, SQL syntax is just a little bit too different than Postgres and other things. You could see LLMs as reducing the barrier to switching off and changing things around. So that's another avenue direction I think is interesting as well.
Yeah, absolutely. I've seen migration tools that are doing a really good job of doing the SQL conversion, and that is a bit more of a, you can call it predictable workload. Andy, I really want to thank you for being on this podcast. You're really always very generous with your insights. I do encourage everyone to go follow along with Andy's work. Block out some time maybe 3-4 months to take his database class. If you're really adventurous and willing to do the work, it's really fun stuff. Even to just go through the lectures, I think even if you just do that, there's so much to learn. Andy, where should people follow along with you?
In terms of like social media,
Yeah. Where are you most active these days?
I try to get off Twitter. I do have an account there, but we post most of the new stuff. We're going to Blue Sky now.
Okay, great.
But there's the YouTube channel. Everything we do is always public. Everything's on YouTube. The course next semester, it'll be a special topics course on query optimization. The lectures certainly will be on YouTube, right? We don't do any advertising. I'm saying, hey, here's the course, and then people find it.
Excellent. You can follow Andy on Blue Sky. We'll have his Twitter or X handle there as well, and a link out to his YouTube course. Andy Pavlo, thank you so much for joining this episode of What's New in Data, and thank you to the listeners for tuning in.
Hey, John, always fun.